Hi everyone, in this session we will learn about capacitance. Capacitance is denoted by C, which is represented like this symbol. First let us see what a capacitance is. When two conducting plates are separated by some dielectric, this is known as capacitance. So it contains two terminals. Okay, this is the basic capacitance. What happens when you apply some potential difference, which is known as voltage, across a capacitor? What happens is there will be charge developed, okay, which may be charge can be positive or negative. So the current starts flowing, so the electrons flow from negative terminal plate to positive terminal, which I am indicating by E, electron flow direction. So the current flows from this direction. So some current flows. Okay, the amount of charge developed across the plates is directly proportional to voltage or potential difference applied. So if I apply the constant of proportionality, Q is nothing but CV. C is known as capacitance. Capacitance depends on physically, it depends on directly proportional to area of cross section of the plate, okay, inversely proportional to distance between the plates. So if I apply the constant of proportionality, it is nothing but this epsilon is called as dielectric constant, which depends on the material used for the dielectric. It contains two components, epsilon naught, epsilon r. Epsilon naught is dielectric constant of air, epsilon r is relative dielectric constant of the material used. Okay, so some current is flowing. Whenever a potential difference is applied, the charge, so electrons are started moving and some current is going. The current is directly proportional to, current is nothing but rate of change of charge. Okay, if I apply Q as CV, here C is a constant, so I is nothing but C into dV by dt. This is the current. Next, we will see about what is the power. Power is nothing but voltage into current. Current here is C dV by dt. So it will be voltage into C into dV by dt. Next thing is energy. The main thing about capacitor is it opposes sudden change in voltage. Whenever the voltage changes across it, okay, these charges, electrons started moving from one plate to another plate, so the current, some current tries to flow between the plates. So it opposes any change in voltage across it. It allows only gradual change in voltage, not sudden change. It stores energy in the form of electric field. Next, I will see what is the energy stored in the capacitor. Energy is nothing but power over time. Integral of power over certain amount of time. Energy contains three components, we know. Okay, voltage, current, time. Voltage and current is nothing but power and over time period. If I apply that one, power is nothing but here CV dV by dt. Okay. Another dt is there, dt gets cancelled. C is a constant. If I remove that out of integration, integral of v dv is nothing but half v square by 2. So it will be half CV square. This is the energy stored in the capacitor. Okay. Next we will see whenever we apply a changing voltage across a capacitor how the current will be. Here I am taking an example. Suppose the voltage is changing like this. Voltage is changing from 0 to 5 in 2 seconds. This is the time on x-axis. It is constant up to 6 seconds. It is changing from 5 to 0 in 2 seconds, that is from 6 seconds to 8 seconds. I is nothing but C into dV by dt. Okay, if I apply that one here, okay, C I am assuming it as 1. So for t from 0 to 2, I is nothing but 1 into dV by dt. dV is final value of voltage minus initial value, that is 5 minus 0 by time, final value of time minus initial value of time. It will be 2.5. That means the current is positive. Its value is 2.5. Next thing is I am taking here. During this portion the voltage is constant. I is nothing but C into dV by dt. If voltage is constant, the constant differentiation is 0. The differentiation of any constant value is 0. So the current becomes 0. So here, as long as the voltage is constant, the current consumed by the capacitor is 0. Next I am taking from 6 to 8. I is nothing but capacitance we assumed as a 1. Final value of voltage is 0 minus initial value by final value of time is 8 minus 6. It will be minus 2.5. Okay, that means the conclusion here is as long as the voltage applied across the capacitor is constant, the current consumed is 0. If a rising value of voltage is applied, there will be a positive current. If a decreasing value of voltage is applied, there will be a negative current consumed. Next I will tell examples where capacitance is used. First example is I am taking, there is some source. Okay, this is some source. Some load is there. Okay, whenever you switch on, load takes, whenever you switch on, okay, both the capacitor and load are connected to source. So source supplies energy to capacitor as well as load. Capacitor stores energy. Whenever the switch is disconnected, okay, there will be for some time this capacitor is going to supply the stored energy to the load. Okay, this in power conditioning applications this is widely used. Okay, here capacitor is used as a storage element, and more it is used for power conditioning. Okay, next I will tell one more example where capacitance is widely used for decoupling capacitor or bypass capacitor. Suppose this is component 1 I am taking. Somewhere some component 2 is there. It can be any component. Suppose these two are connected. Suppose this component is generating some high frequencies. Okay, in order to bypass or decouple from the other circuit, here suppose this component is generating very high frequency noise. If you are other circuit should not be affected by this noise, you have to provide a small amount of capacitance close to this component so that it absorbs most of the high frequency noise generated by this component, which will bypass the high frequency noise generated by this component, which will decouple from the other part of the circuit, suppose component 2 or component 3 or component 4. Okay, the effect of this noise will be very minimal on other components. This capacitor is known as bypass capacitor or decoupling capacitor. How this happens is, if you say the equivalent resistance offered by capacitance, that is known as reactance, capacitive reactance, which is indicated by Xc, which is nothing but 1 by omega c, 1 by 2 pi fc. If frequency is very high, okay, if frequency is very high, the reactance offered is very less. That means for high frequencies, this will offer very low reactance so that it absorbs. Suppose if frequency is low, this offers very high reactance and it will not consume anything. So that will pass to other components. In this application, whatever the high frequency components, this capacitor offers very low value of reactance, so it consumes high frequency noise, whatever generated by this component. Capacitance unit is farad. Thank you.